Live again. This should work now. I should also be live on YouTube, which is not even that important. Yeah, okay, good. So as I was saying, sorry about the interruption. Let me do one more thing here. Pop this out. I should have done this in advance, sorry. So this person reached out and they basically asked, hey, can you upload a model, right? And I did upload the model. I did respond to them, which you should always do when people open GitHub issues. I actually was able to find a PT file, and then thanks to UV, even though the repo is pretty bad, it doesn't have a good requirements txt. So the first thing we have to do is we actually have to encode PyTorch and the Python version and this .map thing, because if we look at the requirements right now, it does have .map, but it's actually missing PyTorch completely, which is not good at all. So the first thing is we're gonna UVify the repo. We'll just do the light version. But in any case, I was, even by using UV myself, I was able to run it and to load the model. But then they came back with this script, which is, let's see here. Okay, so we can copy that. We'll copy that in the working directory. They created a minimal inference example on fast MRI knee validation, but the reconstruction is so strong artifact. So let's check this. Let's load some data. Let's run the neural network because they gave us the script. And let's see, what did we miss? It's possible. One thing I may suspect is the data needs a bit more pre-processing. That's one. The other thing, I may have given them the wrong model. Because I did find more models while searching through the archives. So let's figure it out. Okay, so quick. Okay, so bonus stream, because we gotta get lunch after this, and lunch is very important. So fork the repo, everything on a new branch already. Now I'm gonna run UV init Python 3.9 equals 3.9. Okay, so now we create a Python version and a main which we do not need. We can delete this. But more importantly, we created a Py project toml, okay? So the Python we're going to pin to 390, okay? Let's move the dependencies over because we do not have dependencies. So we know we need, very important, UV add PyTorch, okay? So now how the heck do we add PyTorch 1. This is a very old PyTorch, right? It's 1.9 because this is an old repo, but that's fine because we go to, where do we go to? So let's see here, okay. So we go to install PyTorch, official instructions, and then we also go to UV install PyTorch. I'll show you why we're gonna need. There's a trick here because UV is so good, it has special instructions for PyTorch. Oh, hey, thanks for joining. Doing good. Thanks for joining on Twitch. I'm actually doing like a quick bonus stream. If you just joined, I gotta fix this issue I got in another one of my PhD repos, which is not a bad work. It's not generative, but this is one of my very early works. Like, this was a repo from 5 years ago, and somebody just decided to ask for a model for this is a deep learning work that reconstructs MRI using deep learning, and it's not my worst work. It's one of my first ones, but it still holds up pretty well. It uses these models for, let's see, I don't even remember. Oh, it's an unrolled thing. It like unrolls, it interleaves a deep neural network with an inverse problem solver, some regularization, blah, blah, blah. So it does conjugate gradient, then it calls one network, then it calls another network. So there's sort of like two deep neural networks in tandem here trained together. And yeah, what I wanted to do is, the idea is we kind of at the time, now I know for sure that this works. Okay, so it's not a fake paper, that I can tell you. It's supposed to take MRI scans, which look bad, and turn them into something like this that looks good. And it seems that the models were trained. Now there's two types of MRI scans for knee. There's fat suppressed and non-fat suppressed. If I remember correctly, the darker one is fat suppressed. So this is a knee without fat. This is with fat. Interesting. Yeah, it is, because you can see the fat here on the side of the leg or the knee, and here you can't see it. Okay. And yeah, that's pretty much it. I think we also had a brain model. No, it was all knee. Okay. Yeah, so the idea is that you're supposed to start from a bad looking image, which I actually don't have in the paper, and get to a good one. So then I was able to find the model for the person. I gave them a script, and I was actually able to load it myself. But then they also came back and they gave me a script. Hey, because we're actually seeing bad reconstructions. So let's try and fix this. The first thing is, I know it took me a while offline to actually run this. So I was going to look at PyTorch 1.9 because this is from 5 years ago. So where is it? So I go to install previous versions of PyTorch and then I find exactly 1.9. There we go. So it's PyTorch 191. C PyTorch. The only problem is, how do I do this with UV now? Okay, so these are so old that they're a bit changed. I'm just gonna do a UV add then. Let's see what happens if I do a UV add 191. Linux and Windows. Oh, I see. CUDA 10.2, 11.3. Oh, it has CUDA toolkit too. Is this a typo here? Should be double equal? Not even sure what's... I think so. Interesting. I think the official PyTorch instructions are broken. Oh, but wait. No, we don't want conda. Oh, sorry. It's actually easier. Where is pip? Why no pip? Wheel. Here we go. Okay. Oh, this is what... Okay, perfect. Good. So this is the tag. CUDA plus Q... 111. Okay, so this is what I need then. So what we need to do is we just UV add torch Q911. That's it. So then it installs Python 2. Okay, no solution because why? Oh, there is no version of Torch. Really? Is it pulled or something, or what's happening here? Of course, duh, because I need to link to this. This is why I opened UV. Okay, good. So I need to give it tool UV sources for Torch. Okay, I know it's a bit more complicated with these older ones. So for PyTorch, okay, so I need the index. This platform Windows. Okay, so where's the link then? PyTorch doesn't publish CUDA builds for... Oh, damn, these are so old, though. So should I say Q1111 here? Oh, I see, and I also have to give it this index. Like this. Okay, I think this should work. So what it wants is, so I need 111. Okay, Linux or Windows. And I need this to be exactly the URL they say here in the old instructions. I think. No. Wheel, torch table. Okay. So now if I do, and what do I do? Let me try the add again now. But no, how do I specify torch then? So let's see. Can I just do torch equals 191? And I do UV sync. Why? Why a weird dependency? Is it equal only? No, it's not. Unexpected expected value equal. Can I just not do... what's happening here? Hang on, I'm stumbling again. So if I look at this other one, where did we have, what is it? Disco, right? Yeah. Oh, sorry, it's in quotes, my bad. Oh, I'm so dumb. Okay, duh. Okay, UV sync. Okay, because there is no version of Torch 191. So platform split or Linux, system platform Windows. True. Can call your projects are unsatisfiable. So let's go back to the basics. I definitely know I ran this because I told the guy how I ran it with Torch 1.9. Okay, so let's try running this then. Let's forget about it. Let's do it this way then. So let's reproduce the minimal load. Right, so minimal underscore load. Okay, and then if I do exactly what I told them I would do, UV run. Now there may be there is a trickery here because I instantiated the project. So what if I just say 1.9 UV sync? What if I don't put these? Aha, this one works. But does it pull the CPU or GPU version? I believe it'll pull the CPU version. So then do I just do plus Q111 then maybe? And I get rid of everything? Okay, so at least we have UV sync running, which is good. Okay, perfect, good. Now the only trickery here now is if I run Python, let's see, torch.cuda. No, import torch. Okay, this is fine. Torch. Okay, so it works. Torch.cuda. Oh, really? Available? No. Yeah, no, I didn't install it with GPU. So maybe if I just YOLO with Q111 and I do UV sync. Nuh-uh. Interesting, so what I told the person is a bit wrong. Okay, let me also add the other ones while we're at this. So UV add TQDM, UV add .map, UV add SIGPy. Okay, this should solve everything. And UV add H5Py. Okay, good. So we can delete requirements now. Okay. Yes. I can do UV sync. I can do UV lock. At least we have PyTorch now. We have 1.9, but with CPU. It's not too bad. We can just work like this and debug like this. If we really want to do it fast. And let's just do that for now. Okay, good. So then if I do UV run minimal load, no, okay, so there it is. The pre-trained model I put here. This is the model I gave the person, .pretrained models, .py, of course. Yes, this works. There's a crap ton of warnings. Oh no, there's no, wait a second. So there's another issue here. Import torch. Oh no, but this is actually a warning. Oh, it's a horrible warning, but it is just a warning. Right, I can actually stop here. Yes, oh my god, it's a horrible warning because of NumPy 2.0, I guess. Let me UV sync again. Let me do a trickery then. There is so what NumPy do we have here? So UV pip list 202. This is the issue. There's a way to lock UV. So we can add a, Well, you know what? Let's just specify numpy. Forget about it. So uv add numpy less than 2. Okay, so I found 126.4. So I'm just gonna pin it again because I don't know what it was, but now I do. Okay, so now if I do uv sync, uv lock, this should be synchronized. If I run again, I should have gotten rid of that warning. There we go. Good. Okay, so we have numpy less than 2. Perfect. So this is much closer to the environment. We're still on CPU. Okay, so we're able to load the model. And the way this script works is, I remember at the time in grad school, at least I was smart enough to actually save the model configuration alongside the model weights itself. This is what this h-params is. Very good. So now let's make a data. Actually, let's commit this because we're doing good progress already. So yes, we don't want requirements anymore. Also, this project doesn't even have a README, which I can't believe all these years, but that's fine. So we can add the lock and the Python version. Okay. And we can also type a README. So installation. First install UV. Then run UV sync. Then to activate, we're gonna do it I'm just gonna put these here. The virtual environment, run UVVMV. Okay, I believe this is how it's done, right? UVVMV. Oh no, I don't want to replace it. Oh, is this not how do you activate in UV? Actually, sorry. Oh, interesting. So how do we UV activate? I don't think they even have this concept because you're not supposed to do this. Oh yeah, you're just supposed to run it manually. Yeah. Okay, fine. We'll add instructions for this. So just run. Okay, so we have to be careful. So then to activate, run on Linux or VNV bin activate on Windows to install all dependencies. Okay, so this starts to look at least a bit human because it actually has a README. So we can do, let's see, I'm on my fork, right? Yes, git commit UV project and basic README. Good. Push upstream. Okay, so now we're able to load them all. Now let's go to the real thing. Let's load the person's script and see what's happening here. So for that, we have to make a data folder because I also downloaded some data beforehand. And what I'm gonna do is I'm gonna copy some of the data, which are knee scans. I'm gonna copy 4 knee scans in here. So copy, and where am I here? C. Streaming, what is this? Deep JSONs, data. Okay, the way these MRI scans, they're pretty gigantic, so it's nice. We'll visualize them. Do I have matplotlib? I do not have matplotlib. UV add matplotlib. We're definitely gonna need to plot a bit. Okay, so then I'm gonna lock it down to 394, so it's exactly pinned. There we go. UV sync, UV lock. Done. Okay, good. So we have the data true now and the model, so we can re-update this. Git commit -m. Add matplotlib to deps because we're gonna plot some nice MRI scans. Finally, we can use the person's code now. And they said, what is their problem here? We don't need this. We still have to solve PyTorch for GPU, but I think inference is going to be slow, but it's tolerable. Oh, right, I downloaded this. Okay. Okay, let's see. Let's copy this then. Let me copy it off here. So where is it? Downloads. Here it is. Book. There we go. So minimal working example, inference. Okay, so I have everything here from data gen import MC full fast MRI. Now this is the data loader, if I remember correctly. Yes. I suspect something is fishy here. What I'll do is like this. So data directory will be data, okay? And then I just get all the files. So I sort all the files alphabetically, the H5 files, and there's 4 data, obviously. This is pretty easy. Then I need the file to the model, which is dash. Oh, that person actually followed my instructions exactly. Pre-trained models. And that's it. Then I instantiate the model. And this is the tricky part. I cut data. So these are 3D MRI volumes, and I take a center 2D slice, and I take 5 slices around that slice, and that's the test data. I set the model to eval. I mean, this is not I. He sets the eval. Okay, we actually accidentally also have 4 samples, which is good. Sample next. Move to device. This looks good. Estimate. Yes. Convert to image domain. This is my IFFT to dim -2 -1. This looks okay. Instead of show, let's do save fig plots. Okay, so let's make a plots directory. Okay. Well, if we do this, we want it to be reproducible for the person. So let's do import OS. Plot location, and we're going to do OS make DIRs plots. Exist okay is true. Okay. Okay, so now let's save this to plots /sample I. Do I have an I here? No, I do not have. Sample IDX it's called. .png DPI 300 bbox inches tight. So this is gonna save the estimated MRI scan. Now it would be nice if we plot the ground truth and reconstruction. So there's a crop trickery happening here. Interesting. I wonder what's going wrong here. Okay, let's run it for now. Where does he put the acceleration? Down sample. Okay, so first I want to look here a bit. So let me see what happens here. Yeah, the model, he did not place the model to CUDA, right? Oh, I see. Yeah, towards CUDA. Okay, so he did run on CUDA. So this is going to be CPU for us. Okay, so I can just run now UV. I'm not going to do the activate MWE inference. Towards not compiled. So what? I can't. Oh, I see. He does. Oh, this is my fault because I hard code CUDA in my repo. Ay. So if I go to deep JSON's models, do I have a hard coded CUDA here? Oh, please. .CUDA. Yes, I have a bunch of CUDAs. Is there any way I can get rid of these? Do I need these CUDAs here? I don't think so. So we have two choices now. We either fix the cu.pytorch for good, or we fix the code a bit. And I'm tempted to fix the code, but I want to... Okay, fine. Let's try it this way. This should not even be here. This should just work without it. So let's try this. I mean, the thing is, it will work on CPU for sure, because everything will be on CPU, but... Okay, so no, let's do it this way. So let's remove the CUDA, and then when we fix PyTorch, we'll see if it still runs, and we'll figure out what to do. Yeah, so now everything is on CPU. UV run inference again. Good, perfect. So now I have the H params. right? Yes. Let me see a bit. What did I give this person? So logging false, config image coils, head 0, depth 1, image channel 64, downsample 4, use ACS true, ACS lines. Aha. Aha. This looks suspicious. ACS lines. This is what's happening. And I think we already fixed the issue. Because this should not be 0. MPS kernel, this looks good. Sorry, I'm kind of going over this fast, but unrolls 5.6, crop RSS, learning rate, step size, DK, gradient clip, okay. Start epoch batch size 1, because we didn't have enough GPU memory at the time, which is pretty funny now. Number epochs. Okay, let's see the plot now. I suspect it's that ACS, and if we have time, let me fix it first, and I'll go over what that means quickly. Oh my god. What is this? Okay, well this is pretty bad. What the heck is even happening here? I can't open the H5? What? So data gen line 69. So okay. So what did I load here then? What is the, oh, is it because I downloaded the, I think I downloaded the fast MRI test data, which means there's no ground truth. I need somebody from the lab to upload the file. There's no way for me to solve this then. Okay, let's not despair. So where is it? Line 6 something. Okay, here. So what are these contents? So I'm opening the file. Yeah, I know what's happening here. I downloaded like, okay. This is still fixable. Again, we don't want to fix the code too much. So contents, keys. Yep, there we go. I know exactly what's happening here. So I actually downloaded test data, and there is no ref RSS. The good news, do I even do anything with this? I get the data range. Okay. Oh god, please. And what do I do with data range? I must do some normalization on the outside then. Let's see. So my sample, who uses the sample? My model. So then what keys, what do I touch data underscore range? No, I don't. That's good. And do I touch reconstruction RSS? No, I don't. That's good. Well, you know what? The cheaper fix then. Let's do it this way then. Let's not even load these, because this will not work with actual test data. So delete. We just need the K space, which is the raw MRI data. And what else do I need to do now? Ref RSS. Why is this not erroring out? Interesting. Delete data range. See, I do have an RSS here. I'm very curious how this K space looks like. Are there zeros in it, or is it actually fully sampled? Okay, so this is raw MRI data. If I remember correctly, this means like this: 36 slices of your knee in like horizontal, in like front to back direction, as if somebody was slicing onto your kneecap from front to back. 36 times in that dimension, times 15 coils, what they call like 15 viewing angles in MRI, times, these are 2D images, complex valued. So then how do I get, what do I do with this? Is it just NumPy? Well, in any case, okay, so we have to nuke this and this. Q, again, breakpoint here, no breakpoint here. So let me just run it loose again. Aha, NumPy 120 has deprecated. Seriously, I didn't even know NumPy deprecated int. Okay, so then very easy. UV add NumPy less than 120. Aha, so here's the trickery. We locked ourselves into something. So let me unlock matplotlib and add NumPy 120 again. And I'm gonna have to see what matplotlib locks to, and we'll relock it to that. So NumPy 119.5. Okay, so now we can relock this. So it's exact. And matplotlib has been downgraded to 363. Okay, good. 363. UV sync. UV lock. Good. Again, run the whole thing. Okay, this is a good sign. I think my CPU is actually running. It may take a while, but that's it. So we solved packaging and we're able to run the person's example. Is my CPU running? Yes. No. Oh, assert false. This is all because of CUDA or the environment. It has to be. What? Input key space has to be of even shape. NumPy mod key space -22. Okay, so what is the shape of key space then? We're getting very close, I think. KSP.shape. Oh yeah, this is a disaster. Oh, okay, so something got drastically cut here. 1 is fine, 15 is fine, 64 is fine. What the heck even happened here? Huh. Interesting. I wonder if PyTorch is even the issue then. So when I'm assuming this already happens. Okay, so this happens in data gen. Okay. Okay, some K space. So some trickery happens here. So let's track the K image. Here we go. We're very close here. The sampling mask. I'm starting to remember stuff now. So let's look. What is this K image here? Because it should be at the slice index. So KImage.shape. Good. This is one MRI scan, right? Because I take the whole volume and I take slice number 16. Actually, we can plot this. Yes, we can. Import. Well, let's not, because it's tricky. Okay, so what happens to this then? Line energy. NumPy square. This looks okay because I want to get the energy on these 372 lines, so I compute the energy on the other axis. Okay, so let's stop here then. Actually, let me just put breakpoints so we go. Then I find some deadlines and what do I do here? Now I remember some lines. There is a hidden assumption here that some of the lines are... this is what's happening here. I hard-coded a 160. But I should have hard-coded... I know what's happening here. This only works with 300. Okay, good. I think I know everything now. So I remember I pre-processed the data to have 320 lines before everything happens. So I can't go in with 372 because what's gonna happen, I'll get... this is an approximate middle though, it should be fine. So the middle here will be 372 divided by 2, which is like something, 175. No, 180 something. 186, but then this should catch. This one is front back. Let's see what they are before and after. Well, actually, if I see before, this will tell me. So if it's not divisible by 2, if this is 1, okay, then okay, so I copy this, remove deadlines completely. I would like to see this now, because this, I think this goes odd here. Something weird is happening. Remove it from a frequency representation of the maps as well. We do not have maps. We should not have maps here. Self.maps, maps. When I make this, do I give maps? None. Good, we don't have maps. So this doesn't get hit. Okay, this is another, oh, this is a copy, okay. What is the readout direction? Okay, self-direction. Direction is Y, and I guess I don't touch it. Yes, so this is always Y. So sampling axis, yes, this is right. It's always the lines, the last ones. Get location of this is the trickery here. Use ACS. True. I don't remember what did we see it here. Was it false by chance? Because this h params dot use true. But the problem is ACS lines is 0. Yes, this is where I want to get to. So we use ACS. Direction is Y. And we take the lines for the center slice index, which is what? Okay, so we're gonna have to breakpoint here. Let me see what this ACS is. Wait, so I actually don't use the ACS num lines? Like self ACS lines, this is unused? Oh, nah, it is. Oh, but it's only if else. So it's not this, because I'll definitely hit this branch. Okay, so I was here. Where was I? I hit this branch because downsample is 4. Else. So I'd like to see what num central slices is. And then we do the actual downsampling. Let's see what the candidates are. Outside, they should be outside the central region. Yeah, because the center slice IDX will be a chunk. Here we go. Minus shape divided by 2. This looks okay. Masks are not fed. They are not fed, so we're gonna create a sampling mask, which is also very important, and I should see what it comes down to. And here is where we apply by deletion. K image, where it's not sampled, becomes 0. Oh, and actually I skipped a ton of code. Yeah, I should not have done that. Then we get the ACS. And we get the max and we normalize. We do more initializations. There's a stack here, and this is it. Okay, so now it's time to walk through everything. H params. Let me just keep them here so I know what they are, because it's annoying to swap them. Okay, view, is there a wrap? Yes, okay. So we have these now. So we can always consult them. Next breakpoint. Where am I? Data gen line 71. Okay, data gen line 71. K image. Now this is fine. We saw this. Okay. Does it have a lot of zeros by chance? Does it have 0 lines? Yes, it does have 0 lines. So these are the deadlines on the left and right. Is it all zeros just by chance? If I look at the first coil, everything, and like line 180. No, it's not. So there is real data in the middle. Okay. Continue. 91. So how many deadlines are there? Let's see. So what is line energy? It should be... There we go. This tells us the energy. Okay, so here's the problem. So unfortunately this test, damn it. Okay, so I can't work with test data because the test data has 0. Damn it, I really need an MRI scan. So I can't solve this until somebody from the group uploads that for me. Because I can't, I don't even have enough, damn it. Here's what we can do though. I found one, just a single MRI scan somewhere in storage, but it's a brain one. That's better than nothing, right? Nah, but then I get hit with the 320 issue. I think I'm just gonna YOLO it then. Maybe let's do the brain one. Now, if I could only find the actual slice, but I know I found it. There's no way I didn't find it, right? Research. Sorry, I'm looking through my folders now, but I can't show it on stream. Shouldn't take too long. Let's see, what do we have here? Research. Oh, it's so annoying that I don't even have one. Should I download? But I can't. I don't have, I mean, I can download, but it's gonna take like 6 hours to download because the validation data is like 90 gigabytes or something. And I know it took a while. Well, not 6 hours, but yeah, it kind of defeats the whole point. So we need something fully sampled. Okay, let's do it another way then. Let's try to find leaks online. What if somebody leaks? So fast MRI, single knee volume. Download. I wonder if we uploaded it. Let me check the other, what is it called? Langevin UTCSI lab. Nah, we never uploaded data. Oh my god, does this work? Wait, does this link, after all these years, is it still active? Yes. Oh, wait, what is this? Data sets? 5 gigabytes. I think this is it. Well, this is from our other paper, but this was still me organizing these. Okay, so this is gonna take like what? 4 minutes, not too bad. Okay, so we did leak data ourselves. Yeah, data sets. Fast MRI knees. Oh man, I really hope we can find that. I just need just one knee scan. And I know, I think I even uploaded it somewhere. Now, if you go here, they want you to download everything, which is really annoying. They don't let you download like one sample. Maybe here? No. Maybe this person leaked something? No, they only have the weights. What is this? Open data on AWS? No. Wait, what about the tutorial notebook? No, but I'm guessing they don't have data. File name, I mean, sure, but I want this. Yeah, it does not. Come on, like they don't even have one sample. Well, I can click this. I don't know what the heck this is. What? Did they put all the files here? Can I download just one? Okay, what the heck is this? V03? No, this is... No, this is the repo, not the... Yeah, no, they wouldn't put data here, obviously. Oh, is it FastMRI Plus? There's a trickery here, because somebody improved the data set. Did they re-release it? Is there no GitHub? There is a GitHub. Maybe they re-released it. The FastMRI. So how do I get this? Example. Annotations. Come on. No, it's annotated. No, you still have to get the raw data. Okay, download is done though. All right, so let's see what's happening here with dataset *gz. So we have to unzip this twice though, which is annoying. Okay, so it'll be like a minute. Let's keep looking for other stuff though. No, this is not right. No. Everybody's uploading model weights. Okay, what is this, a mirror? Okay, yeah, it got taken down, obviously. Are there any issues? Code weights only, inference scripts. It's 3 terabytes in total. Is there any way I can download? No, I don't want to download these. These are way too big. Damn it, if I could get the multi-coil, the knee multi-coil. Well, no, they clump. Yeah, these are too large. No, this is just a publication. Okay, is it done unzipping? It is done unzipping. We gotta do it one more time. Okay, I think we found them. Yes, okay. So I don't even remember what I did, but whatever this... Oh, no, this is from our paper. Yes, we found them. Okay. So we leaked FastMRI data ourselves, which is not good, but okay, good. Good. So we are done now. Okay, so, well, leaking data is a different story, but finally we can proceed now. So, something is wrong with the decompression. I don't even care, but let me paste this. Where were we? So C. Oh, there we go. It finished streaming. So let me open a new tab. Just 1 second. It's here. So let me delete the brain data. It's not good. Okay, we paste the knee data back in, and I think we are actually done, which is pretty good. Yes. Okay, thank God we leaked some of them ourselves. Yep, these are the knees, and that's what we need. Replace the files. Okay, so now we magically have 2 samples, okay? So I'm gonna have to change the person's script to don't do inference on everything, but on range. Where the heck is data? Length of val files, because that's what we want to do, I think. Or no, length of val data set, all right? Okay, so we can start everything again now. So we have the data. It's from our own paper, but it's fine. Again, debugging line by line. Okay. Good. Data gen 71. Let's see how the K space looks like now. And actually these have that key. Okay, perfect. It's exactly the same scan as before. So 183. Perfect. So these are raw MRI files. Okay, thank God. Okay. Wait. What is this? Is it a full slice? I mean a full volume? Yes, it is. So we actually leaked files. Okay, well, it doesn't matter. It's fine. It does matter, but we'll deal with that later. Deadlines. So now what's the line energy? Yes, perfect. So it's only on the sides. Okay, so this is real data. Okay, we're gonna fix it now. So the deadlines are on the sides. Okay, then we remove the deadlines. How many are there in front? Even number, exactly as expected. And the back, exactly as expected. Symmetric tool. K image after the deadline removal. What is it? 332. Okay. Okay, good. I wonder if we should crop to... Okay, next. Where? So what happened here? Center slice index. Ah, this is the ACS. Okay, very good. So we're keeping these. So we're not destroying the structure in the knee. So we're keeping 27 central ones. And we cut... Oh, sorry. Again. What are we gonna cut? Oh, come on. These lines, how many are we cutting? 305. No. These are the lines which we will cut from. But if I take this and I sum the center slice, I should get exactly... Oh, sorry. Plus the length. 332, which is exactly my data shape, right? Yes, okay. So everything looks good so far. Next. Direction Y. The sampling mask. So the sampling mask will have ones and zeros. There we go. Trues and falses for which ones we throw away. Or is it keep? It's keep, actually. So we're only gonna... Oh yeah, it's keep. Yeah, because we're gonna keep the center. And very few on the side. What the heck? We're throwing away so many. What is the H params down sample? 4. So what is the sum of the mask? Because it should be about 83 divided by length of the mask. Yeah, it's 4. Okay, exactly. So we keep... Okay, perfect. So we keep exactly... Hey, do I have... oh, thanks for joining. Do I have the Twitch title with DSPy? Because I'm not doing DSPy today. Sorry about that. Oh, no, it's my tag. Oh, sorry. Well, DSPy is... let's just change this magically to PyTorch. Because I am doing a bunch of PyTorch stuff today. DSPy is another package. It's for large language models, but I'm not working on it today. I'm still doing AI though. Thanks for joining. Thanks for chatting. But yeah, I'm doing more basic PyTorch. We're actually going through just some data undersampling right now. And then we're doing a medical imaging application. So we're pretty close to plotting, but let me see first. Okay, so we're actually at the end here. Okay, so we got the mask. Then we're gonna delete. I don't even know why I stopped here twice. I should just, it's the same thing. Nothing else happened, right? Oh no, actually, wait, we deleted. Okay, so K image. Okay, so it has a ton of zeros now, all right? So if I do torch sum of absolute values on the axis 0, 1. Oh, I see. I'm in NumPy world. I'm not even in tensor world yet. Oh, there we go. Yeah, so we deleted a bunch of lines. We only kept the center from our data. Do I take the ACS then? What is self-use ACS? Okay, so I do have this ACS, and it should have a length of what? 27, exactly, we knew that, right? Because it's the 27 lines. Then I do some normalization. Anything weird here? That's it, I'm done. So then I have... Oh, okay, so then I can run the script. Actually, yeah. Okay, normalized image. So if I press C now, now it should run the model. Something is still fishy though, because I swear... Okay, we're actually done now. So we finished one sample. Do we have a plot? Yes, we do have a plot. Okay, so now I get what the person is saying. Yeah. Okay, so to fix this, first we have to see what the raw data looks like. Yeah, something is broken somewhere for sure here. Okay, now I get it. Okay. So what happens is we have a sample. Let me cut the breakpoints. Huh. Interesting. Yeah, that doesn't look like the... I wonder if the data going in is fine. It must be a normalization issue. Okay, so then let's plot the raw data then, which is in sample. Plot sample before reconstruction. Figure im show. Okay. What is it? Sample. What key do I have? Where's the raw data? KSP. And I just need to take... I do the IFFT. Okay. So under sampled RSS is sample K-space. So I do the IFFT of this, and I do the sum of powers, torch sum square abs on the first axis. Oh, he uses TH. Okay, fine. I'm just gonna do him. Well, okay, fine. So then I should show this image under sampled RSS .cpu cmap gray, and I should just... Oh, PLTX is off. Save fig close. Under sample. Let's see. This should kind of look like a needle. That's the thing. Oh, I see. It's complex data. Okay. So under sampled CPLX will be sample KS space ... 0 plus 1J times sample K space ... 1, because I need to reform it back, and then I can do this. I take the IFFT. Right. Let's see again. Why? Does this have everything in it, or what's happening here? Like, do I have all the case space? Oh, I see. It has a fake batch access. Ugh, I hate this. Okay. So I just have to peel off the batch. Okay. Undersample 0. Yes, it does look like a knee. Okay. All right. So we know we enter with this. We enter with this data, but we exit with bad looking knees. They preserve some structure, but not too much. Okay, I actually need to stop this. Range 2 is enough. Sorry. Okay. Okay, so how the heck do we fix this then? Come on, what is it? It's gotta be a normalization issue, right? Let me do this. Let me see how I trained the model. Are there any hints in how I trained the model? So this is... So I used to take the training data from here. Let's assume this is raw MRI data, okay? 64 blocks, estimated, lambda train, true init, warm start. This looks okay. Fine tune, warm start, batch size 1, pix, SSIM. I create the directory, then I create the data set. So it's exactly the same function to create the train data set, is it not? It definitely is. Train files, num slices, center slice, downsample. Did I mess with the data before? And I don't have this data anymore, right? Yeah, I don't have it. So it looks suspiciously similar, but what am I doing wrong? Why is it like weird? Should we debug after? Am I not loading the network? Where is the load? What if I switch this to strict true? What happens here? It still loads, which is good, actually. Yeah, okay, that means actually everything is... this is the model that I found. Do I have the wrong model? Okay, so that I can try because I had found newer models. Yeah, so this looks good. Okay, so let me look for... Let me try some other weights then. For the actual model. Yeah, still bad recon. Why bad recon? Is he doing anything weird here? Oh, maybe, okay, wait a second. What's up with all this padding? Because I kind of don't like it. So why don't we do it this way? Let's see, what is the estimated case space? Because that's really what we care about. Then we just pad it. Kind of want to see by how much we pad it. So, estimated case space. Okay, so this is the same shape. So now here's the thing. If I take an IFFT of this... let's see. So I do all this. And I can just do an estimated coil image. I take the IFFT of the first sample in the case space on dimension... No, on dimensions -1, -2, because that's what this thing does. Am I not supposed to FFT shift? Uh-huh. This looks a bit dubious, I think. Maybe not. No, I am supposed to FFT shift. So I take the IFFT, my IFFT. Then we get the single image. Okay, and then we can just plot it, right? So coil 0 or estimated coil 0 for a sample. Because I want to see before any padding. If this looks bad, that means something is bad in the model itself. Okay, what is it? It does look bad, right? Here's another trick then. What if I change the undersampling only to 2? Does it look better? Or actually, what if I change it to 1? So 1 means nothing, no undersampling. This should, well, the model does something to it. So maybe it really is the wrong model. Okay, that's easily fixable because I found something else. Just have to remember where I found it. So research. Okay, so let's see what happens at undersampling 1. No, the coil is quiet, but there's still artifacts. Yeah, it's still bad. Yup, okay, so something is wrong here, either with the data or the model. What is wrong? We can put this back because it's not the undersampling. Wait, is this what it was? Yes. What is wrong here? There is some weird padding, but this should be okay. Well, actually, I know how to... Oh, wait a second. I know how to... Here's a trickery we can do. So here's how we can test if the padding is right or wrong. We can just override this with the perfect K-space data. So what is it called? Ground truth KSP. So it's as if my estimation was perfect. I should see nothing now, or I should see the right crop. Okay, so this is good. This will tell us that everything that's happening here is okay, and we don't have to worry. It's either a scaling issue or a model issue. I just gave them the wrong weights, and it was trained on some other scaling factor, which sounds fixable. At least I know. Okay, let me keep looking for more models while this thing works. Golden code knee. Is this the model I gave him? Okay, so let's see what happened here. Yeah, there we go. So this is perfect. So the post, so this is what we should see. This is the perfect estimate for these two knees. And perfect. Oh, good. Okay, so we know it's nothing after this. So it's something bad goes here. We know the data enters right because it also reconstructs right. Okay, we can keep the plot. So something happens in the model. Something happens in the model. What is meta unrolls end? It's 6. Yes. Cancel. And I give it the full sample. What does my model do? It takes the sample, K-space mask. The mode is deep JSONs, obviously. No, this looks okay. I guess worst case, we can start debugging these at different iterations. Yeah, mapping it should be estimated. H params. Yes, image in it and map in it. Yes, it goes into because this is the whole point of the paper. It estimates both the image and the maps at the same time. Well, alternating. Okay, so this looks okay-ish. No, there's no way this is wrong because I haven't touched this code in years. Like, if this is wrong, the whole thing is wrong. Which could be the case, but then it's not because you want to use this. This is exactly the same code used in training. So I guess the real check would be we would have to retrain the model. But before we do that, okay, so let me find more weights. So what did I give this person? What? I give them, and this is LR2 image. Oh. What does that image stand for? Interesting. So how do I save the model name? What is the significance of that image? No, because I know other people tried to train this because I had other issues many years ago complaining about something else, and then they fixed it, and I'm assuming training was working. Where the heck do I save this? Torch.save. Best weights. Ah, okay. I gave him the wrong model then. Yeah. Okay, this is easy fix then. Did I give them the wrong model? What is the size of this file? Let me see here. Streaming deep chase. 5274. Okay, I guess we'll just try another model. Other model. Well, let me call this where I found it. Golden Mikai Ni. Okay, so let's just load another model then. So then what we do is we just point to pre-trained models. Oh, please work. Did I mistype it? Oh, did I not save this? Duh, okay. I didn't press save. Hey, thanks for stopping by. I'm actually debugging some PyTorch code where I'm trying to load this model and reconstruct knee MRI scans from undersampled measurements. Okay, it still doesn't work. It's still blurry. So it's not this model either. So what did I give them then? It kind of smells a bit closer. So this had validation samples. I have the, yeah, this should be pristine though. It's not, yeah, it looks pretty bad, right? I'm getting this blurriness. The thing is, well, what I'm trying to do is, I have this repo from grad school from many years ago. Thanks for stopping by, but let me do a walkthrough here. So what happened is, I'd have this repo from grad school and this paper from like 5 years ago. And I'm pretty sure it kind of works. Like there's training. There's definitely training here. And at some point somebody trained this, but then I got an issue that they're getting bad. Well, somebody asked me to upload a pre-trained model and I thought I found it, but then they also complained that they seem to have properly followed the instructions and they the reconstruction has strong artifacts, so that definitely seems to be the case. It's not only the noise, it should look. Here's what happens. So there's an undersample. What if I put the undersampling to 1? Because this is basically no undersampling. So the way MRI works, it's gonna look blurrier the more you downsample it. That's actually how it works when you go get an MRI scan. And this AI model is supposed to reconstruct it or to improve the quality. The problem is I can't find the model weights. It seems like it. But then if I look, yeah, something like, see, this is the thing, even with 1, like now I put perfect data in and it messes it up. No, there's, let me think here. So let me look at something else. So what is the magnitude of the data coming in and out? I suspect it's either the wrong model weights or I'm normalizing the data wrong. So how does this work? So I get estimated k-space and I have sample k-space for the input. Sample k-space. Should I try some factors? Nah, we can't try. I mean, we can try a linear sweep for factors. But you know what? Hang on, because I have the plot script. I have the training script. It must work. There's no way. Unless I fiddled with data myself. Was I searching for data back at the time? I can't remember what. The only missing piece is I don't remember what it was trained on. And there, I mean, it's not. I don't remember. It's not that I don't remember, but it's actually gone because it's like from 5 years ago. And also I don't have all the training data set because it's like 6 terabytes. So worst case, I'm downloading that offline and we'll stream again. But before that, so what do I go in with? Sample keys. I think it's k-space. So I go in with this thing and I come out with the same thing and complex. So let's put k-space or input k-space. Let's take the k-space and let's turn it into complex because I'm lazy. .1 input k-space dot shape. So this has a ton of zeros in it because that's the point of undersampling. What I want to look at though is, so what is a line that is not 0? It's somewhere around the middle, like 180. Okay, good. So what is the average absolute value of this? Seriously, okay. This is a tensor, or what is it then? Yeah, it's a tensor. Okay, so then I have to go to Torch World. TH. So it's like 0016. What is the average energy I come out with then? In estimated k-space, exactly the same thing. Okay, so I'm destroying. Yeah, there's a scaling issue then, right? Because I come out basically with 0, right? Because I go in with data. Yeah, okay, I know what's happening here. So there's a mismatch between what the model was trained on and what data I put in. Let me open the training script. So this, now I found a folder called Golden Code Ni. Which, what behavior? What do you mean? Well, the thing is, I mean, there's still some knee structure in here, kind of vague-ish, but it's basically like out of distribution, right? Now, here's a cheap shot I can do then. It takes MRI as input, it outputs MRI too. Well, okay, well, we have to go to the paper. Let me just skim it over. So, it takes MRI with zeros in it as input, and it's supposed to fill those zeros in, basically. right? So this is the paper. I can drop this in the chat. Yeah, it takes MRI and it alternates between a deterministic reconstruction using a non-deep learning algorithm called, it's just gradient descent with conjugate gradient, right? So it does gradient descent on the measurements to try to fill in the data. Then it passes through a network. Then it does gradient descent on the what's called an MRI maps and passes those through the network, because the data you observe in MRI is a product of two things: the maps times the real data. The goal is to recover the real data, but we also don't have the maps. So then it's a convolution. And then in this paper, we say we're just going to estimate both of them at the same time. We don't really do anything with the maps, but they're here. Where is it? Estimated map kernel, if you would ever want to plot these. But then what we care about is I don't think it is. No, conjugate gradient is deterministic. The network itself is deterministic. No, it's an unrolled method. Like, it's not a sampling-based method. And it also starts from deterministic. Everything starts from a deterministic map kernel too. So I don't have any random estimates for these. I have them systematically set to something. I don't remember what the map kernel starts from. It starts just from a 1 and zeros everywhere else, or something like that, like an impulse kernel. And then the image starts from the measurements. It is probabilistic in the sense that the data that I throw away is random, but I guess this is not, I don't know, it should be seeded. It's probably not seeded, but assuming you fix the data you throw away, then you should get the same outcome twice. What was I gonna do? Now, a cheap shot that we can do is, so I bet you there's a scaling issue here. The problem is I don't have the data I trained on in grad school, because I wonder if I trained on raw. I only found 2 data samples. So what was I gonna do? Oh shit. Okay, let me load. Okay, so I found the folder. I can't show you the folder structure because I can't leak the. Well, actually, I don't even have it set up to. But here's what I did. So I found the test script. Open. So this was done November 17, 2020. Oh my god, it's like... what do you mean? Like the whole undersampling thing, or the problem that we see? No, and well, that's the problem, because you don't. So you need to know those maps, the sensitivity maps somehow, and they usually pre-calibrate those. Because if you fix the scanner, it's like they're pretty much like they're actually placed around your body, right? And they just illuminate different parts of your body in the scan. Like, for example, this data has 15 maps. Where is it? Estimated k-space dot shape. So there's actually 15 two-dimensional images of your knee, and then you have to combine all of them. Each of them has its own map. And if you look at how they physically look, they light up, or they increase the signal amplitude in different physical parts around the knee. So it's pretty nice, but they are fixed usually. So they usually pre-estimate these. But assuming, let's say you buy a new scanner, right, or something, or you don't know what the maps are, you would have to estimate. No, they're all at the same frequency, but they're different physical locations. So they're actually physically placed around your body. But they all capture the same signal at the same frequency. It's like, if you know wireless comms, it's like a multi-antenna receiver. Or, even your phone has like 4 antennas usually placed at different parts. It's pretty much the same thing. If your question is more general, MRI itself, yes, it does work through waves. Yes, yeah, that's how MRI works. Yeah, you're basically imaging your body, but it's safe radiation. It's a spectrum that's well, it's non-ionizing radiation, so it doesn't actually tear through your body. It's not like X-ray, which I don't know how that works, but I know that X-ray is bad because it actually I don't know if it's just because it's a different spectrum. I think it is. Yeah, X-ray, it's pretty bad though, because it actually physically tears through your body. MRI happens at other frequencies. I don't know. I was never an MRI expert. Okay, so anyways, so what the heck? So this is the script from grad school, and it's in the folder called Golden. Now it's called Attention because there was some other stuff. What is UVB? Like ultra band something? Ultraviolet? Oh yeah, okay, ultraviolet. No, MRI is something. Actually, I don't know what MRI is. Yeah, I should know this. Well, what is? Okay, ultraviolet. Yeah, what is MRI frequency? Okay, so it's about 64 to 298, so it's pretty low then. It's close to cell phones actually, right? Cell phones are like 2000 megahertz. So yeah, it's pretty much harmless then. Okay, so what the heck was I doing here? Now the big question is, I was loading the data from here. Was this raw data? Let's assume it was. So I take center slice. H params deep JSONs, map mode set, false. Oh no, but I don't have attention. Okay, no, this is not the right code. Yeah, I know, but this was like, I mean, it's not quite like that because, no, so anybody can download fast MRI, but it's, I just didn't do it because it's 4 terabytes. I should, the problem is I don't know if you're even allowed to, I don't even know how it works. It's, you have to apply for access for fast MRI, which you can do at home. Like they'll give you access for it. Ideally, I should find... Okay, so what I need to find is... So, okay, this is not the right script. It's not, because this is actually with attention. And I don't know what I'm doing, but where is it? Come on. This is the one. Test unroll complex JSONs. Same folder that I used. This also has attention bullshit. Like, did I do attention here? No, this must be something else from grad school then. I'm in the wrong... So maybe this explains why... Is this the model I gave the person? 6078. It's the same as this one. Let me try this model then. Golden. Let's give this another shot. So I just pasted this golden thing. Just call it golden. Quit. Break. Oh, come on. Okay. Now, not to mention that I had to redo the whole environment because I had to find PyTorch, and I didn't even get PyTorch running on GPU because it's a very old PyTorch, but I was able to at least get UV working and pin these down a bit. So that, it's a bit slow because they're running on my CPU. Oh, come on, it's not this one either. Nah, it's not this one either. Same issue. Interesting. So it's not the 6078. What about 25 model? And 1 and 2 and 6. 5274. This is the other model I tried to give the person. Okay, so this is the folder I found, so it's not good. Where would it be then? Okay, well then I'm forced to try. Was it on the 320 slices? Let me look at the train here a bit. Maybe I can guess what's happening from the train. I think this is good. Do I even have a tension though? Map init, image init, estimated. Use, okay, this is for short training, 15.15.9. Yes, 6.6. This is what I gave the person. Batch size 1, step size 10. Okay, so maybe I need to give them circular model coil loss. Oh, is this the fix? Wait a second. What does circular model mean? Golden knee. Circular model coil loss. Let me try this one. So, circular. I wonder if I gave them... Okay, so the model, let's see. Circular. No, it's still not this one. Wild. It must be the data then. It must be the fast MRI data. I wonder if I trained on 320 times 320 crops. Was I cropping the H to square? I think so. Shit. Should I crop the lines? Should I crop the image? So I take it to IFFT and I can crop there to square. So how can I tell? Can I tell from this code if I was expecting the data to be square? Because right now the raw data is much more vertical. It's like 640 times 330. I wonder if I was cropping the vertical axis, but then you have to be careful because you can't crop in the K-space and the frequency domain. You have to do IFFT, crop there, and do IFFT back. That would be a giant. Aha, here's the trick. Yes, I was cropping. Skip samples with large field of view. Okay, this is what's happening. I was never training on these. Yup, so this is the vertical axis because it's the second one from the last. So if a sample is too short or too tall, I just don't train on it. And now when I test on gigantic samples because yes, I remember now. This must be it. Good. Okay, this is kind of fixable. Unfortunately, the code that I used to crop I lost, but I remember my advisor was always bugging me, crop correctly. You cannot crop the K-space directly. So what do I put in here? Sample.keys, sample ksp.shape. Yeah, so that 640 is a disaster. Okay. Yes, I remember now because I know what I did. I pre-cropped all my data to disk and I saved it under the same files, which sounds really bad. Where am I? Oh, train. So I skipped these with large FLV, sample case space. And the thing is, my data loader does not crop. So that means the data on disk must have been cropped. Yes, 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 yes. Okay, so how do we crop then? When do we crop? Well, let's do it nice. Shit. When do we crop? Let me practice a crop first, because I need to remember how to crop correctly. That's a trickery too. Now, the other thing with MRI is that the raw data is not an image. It is the FFT of the image. So I have the files. Okay, so crop files. It slices, coils, 2D. But then it's also, actually, I'll just show it. Also, so crop files in place. Okay, so for file and val files, contents is, well, how do I load this? Is it H5 something? Here we go. So with H5 file. So let me just do this in place, and then I'll save it to disk, and then I'll we'll figure out what to do from there. Well, first let's plot. So, okay, this has to be it. Yes, okay. I think this is solvable. So, for file, with H55 file as contents. Oh, seriously, I don't have NumPy here. Okay, so then you get, so you have to slice it somewhere. So let's get the full volume. Okay, so get space for full volume. This is going to be a gigantic object. Then we're going to crop each slice separately. Okay, so for slice in range, because I remember the slices are the first axis. Okay, well, actually I can do this for slice. I believe this works in K image. We can rate here. Plot in K-space. So this is, or actually plot raw data. This is how the raw data looks like, and it's not gonna look like a knee. Let's do a nice figure then. Where do I do the figure? Well, actually, okay, we also want central slices. So the other thing is, if you look at slices too far away or too in front or too in back, they look bad. And the way I do it here is, I believe I magically declare the central slice to be 15, and then I do plus minus 5. This is because I know the data set. Where's the heck is that train script? Well, that's because the slices, they go from the front of your knee to the back. There's also directions to MRI scanning, right? So this data set is from the front, like as if it was approaching towards you. And then it passes through you like vertically, let's put it that way. I remember what it's called. And then it comes out through the back of your knee. So then if you look at slices that are, and I believe there was about 36 slices. So then if you look at the ones that are too early, you won't see anything. So then the center slice is the one that's in the middle of your knee. Again, as if you were standing upright, and it's like a panel, it's like a screen door coming towards you. Where the heck is that 15? Here it is, center slice, numpys. Yeah, so this is, I just hard coded it for, this is how the fast MRI data set looks like. So then we want to do 15 minus 5 plus 5, so from 10 to 20, okay? So let's plot from 10 to 21, I guess. Okay, so then we'll get slice will be K image at the slice index. Then we can plot slice index. Now this is also multi-coil, so now this is a 3D tensor. It has coils and 2D. So we can plot a coil. We're not going to plot all 15 of them. So we'll do, let me just do separate figures then. So we're gonna do slice. The coils are not ordered in any special way. So let's just plot. Now this is 2D, so we have to plot the absolute value. Again, we can't plot the complex tensor. It also has a phase. And we can call this raw. No, we can call this K-space coil 0. Slice. What is it? Slice index. Okay. Now plot a coil in image space. So what we do is image. Well, first we can convert all the coils at the same time, because we have an IFFT, which is a custom function of slice. That's it. Now this is pretty benign. You do an FFT show. Okay, I'm also gonna need the FFT brother then. Okay. Let's see how this one looks like. So now I get 15 coils, but I get them in image space. So then if I plot image coil 0, okay, this is gonna look different. Crop in image space, crop vertically in image space, cropped image. Why? I don't think we use, yeah, I haven't used Laplace in many years. I don't even remember how it works. What was I saying? So we have to crop this. How the heck do I crop? So what do we need to crop? This is critical. I'm gonna guess 320. I know what's happening here. So 320. Yeah, let's do 320. Okay, so how do we... So crop size 320. Is there an easy way to crop, or do I have to do like weird calculations? Because I really don't want to do weird calculations. Fine. Okay, so extra rows will be image.shape -2 minus 320. Well, yes. And then we're just gonna do image cut half of the rows from the front and half of the rows from the back. That's it. And that's it. We don't need the last axis. And again, plot it. I mean, the plot is trivial. We're not going to plot it and convert back to K-space. The plot is trivial here, right? Okay, so now we get cropped, in quotes, K-space, which is really the FFT of the cropped image. And we have to put it back now. So K image cropped will be zeros. Okay. And it has to be a zeros. Well, let's just fill the whole volume. Forget about it. So we'll do... Yeah, we'll do this... Okay, we'll do it... Yeah, we're gonna do it for everything. For slice in K image. So I need to preserve the first shape, slices. I need to preserve the second shape, coils. I don't touch that one. The third shape is now the crop size, and the last shape is still preserved. And this should fit perfectly. So now I can just store this back. So for slice... Oh, come on. For slice IDX, enumerate. Okay. And I can plot, and it should fit perfectly here. So K image cropped at this slice should be, and just because I'm paranoid, I'm gonna do a deep copy so it doesn't change in place. Okay. And once I have everything for this file, save to new file. And I don't know how to save H5. How to save H5 dataset file, Python. Create dataset, and it has to be called exactly what it was. So how did I load it? I have to... Okay, so let's see. Cropped file will be... Oh, I have to do some path shenanigans here. Okay, I need to... Hang on. So path file... How do I change the file name with pathlib? Change file name with pathlib. Because I really don't want to pull out the extension and do it dumb. Oh, is it with name? Okay, with name. Okay, perfect. So it's original file with name. Okay, so then we knew it's path file with name. Oh shit, but I need to know... Oh, come on. I need to know the original... Append suffix to file name with pathlib. Do I have this? I have to build it myself. Yeah, this is exactly what I want. Append to file name underscore processed. So what do I do? Path. I'm just gonna take these. So yeah. Path. So this, right? Yes. Okay. And this is file. And the suffix to add is underscore cropped. And I need from pathlib import path. Okay, so I have the crop file, and finally I need to save it. So what is it? Cropped file W. What is it called? It has to be called exactly K space, and the data is the K image cropped. Do I even need this? Probably not. All right, so let's see. Breakpoint. This should run now. And it should also produce a crap ton of plots, but it's okay. Okay, I have to work in TensorWorld. Interesting. Can I work in TensorWorld? Probably. Yeah, this looks pretty benign here, right? Okay, let me work in TensorWorld then. Fine. It's a... Oh, no. So it's TH zeros. Yeah. Okay. This is fine. This is... No, okay, we're not gonna do this, never mind. So instead, what we're doing is we're just gonna work in TensorWorld here. Does NumPy have IFFT? No, but I need the shift tool. Oh, okay, so let's work in TensorWorld here. And then NumPy back. So it's guarded, and where's the FFT? Here it is, NumPy back. TH tensor. Okay. Okay, it's plotting. Oh my god, it's gonna plot. Okay, so these are the slices, as if the scan is approaching your knee from the front, right? So it's coming. It's a lot of noise because there's no tissue signal. Then your knee starts to show up, your kneecap. There's more signal, so relative to the noise, the noise. I mean, on absolute scale, the noise is the same. Then your knee is like in full-fledged thing, and then it cuts all the way to the back. But sorry, remember, this is just one coil. Okay, so this is the other thing. Remember, this is just one coil. You can see where the coil is because you only see the top left part of your knee here. If I look at another coil, I'm gonna see some other illuminations, right? For example, okay, and this is an image space. The raw case space data doesn't really make much sense because it's Fourier domain data, right? So you'll just see like stars and things. Everything seems to have worked out. Okay, so now we have 2 cropped files. So let me make a new folder. Actually, we should do this. Data raw. Let me copy these. Yeah, something like that. And then... Oh god, but I need this to... so if core dir is data raw, then we're gonna do all this thing. Well, no, let's just do it this way. If crop... I'm just gonna disable it. Because we don't want to do this twice, because, well, actually twice will have no effect. Crop on crop will not do anything. Okay, so now we can go back. I can delete these. Oh god, I really hope this works. So then if I look in the data folder, I see cropped stuff now. Okay, this is... I'm overwriting my thing here. 320. So now when I reload this data, I should see 320. Well, it's just YOLO it, I guess. Which model do I have? Let me try what I gave the person the first time, because maybe that was the right model all along. Okay. Oh, it's not. Where is the model? Oh, here it is. Okay. This is it. Just YOLO it. Oh, come on, please. No, don't YOLO it. Let's delete the plots because there's too many plots. We won't be able to tell anything. We can always do those again. It's gotta be this one, I swear. Oh, it's not this one either. Huh. Let me try the other models. Maybe there's still hope. So what did I have here? Golden. Maybe this is the wrong blocks for... So how was I saving this model? Where was I saving it? Local dir, which is what? Yeah, it's exactly this convention. And what the heck is blocks? Different types of artifacts. Huh. It's definitely closer, but not quite. Something is still off here. Well, okay, worst case, I'm just gonna retrain the model from scratch because I have the training script and it's on the GitHub, so we'll see how that goes. It's fine. We're fixing this for the person. There's no way we're not. One way or the other. Nah, there's still artifacts. It kind of looks like a knee, but kind of not. Yeah, but I did all this. It's like 11 to. What is 11 to 26? You mean the slices or? Yeah, so I must look right then, because I look at what? At center. Yeah, so I start from 10. I mean, okay, it's kind of getting there. It's a bit closer. What am I missing though? Why is this? It's got to be some other data science thing. Did I do anything weird? No, I didn't do anything weird, right? Because okay, let's double check the crop. Maybe I cropped to some, I don't know, maybe hopefully my cropping is bad. I doubt it though. Sample.keys, sample kspace dot shape. Yeah, it's 320 now, 336. So I trained models knee circular model coil loss. Maybe it's not in here then. Golden code. No, wait, hang on. I have to switch to this one. Where else could it be? What I don't understand is that this folder definitely works, because I was taking, okay, so definitely works, right? Because I was taking snapshots. This is at the 19th epoch. And this is all automated. If I look at train here, there's a plot code. There we go, validation samples, epoch, whatever. And this is exactly that file. So if I run the whole training again, it'll definitely work, which implies I have to download the fast MRI dataset. So I have to cut the lines. No, but I do cut the lines. There's no, because earlier in the stream, I also cut the deadlines from left and right, and I put them back here as padding. I don't think, or is it that? I don't think it's 320, 320. Oh, is it? Why? Because wait a second. Because the image is square. No. Wait. But that's an RSS. I cropped the RSS. Let me read the paper. Yeah, maybe you're right. Maybe it is something in the paper. Maybe I say some things here. Sensitivity map. E-Spirit. A bunch of bullshit here. Experimental. For training, we use the 5 central slices. Okay. Do I have a supplementary here? Okay, I have a supplementary. I don't think the thing is where do I say 320? Yeah, no. I know what's happening here. I have this. No. So hang on. So this is what we're seeing. This is a 320 crop, but this is after estimation though. It's just for plotting purposes. So here it is. It's the central crop just for the plot. And I do this also in the training, because what I do at training, where the heck is the training plot? Oh, here we go. There it is. Exactly the same crop, RSS. And then I plot it and I save it to val samples. So I know this works. Like if I open the validation samples, it looks really nice. So if I retrain this thing, it'll definitely work. H-param state dict. Let me check the H-params and compare them to this folder. I don't understand why I have this attention. Do I even have attention crap though? So what is H params? Deep JSONs logging false. Yeah, I do have attention. Image coils 01. This is the script. It has to be. It's literally this script. Channel 64, image blocks 4. Downsample 4. Use ACS true. ACS lines 0. Use ImageNet true. Use MapNet true. Map init estimated. Estimated. Map normalized true. Image architecture ResNet. MPS kernel shape. 15.15.9. L2 init 01 true true. Crop RSS. 6 unrolls. 6 preload. Learning rate 02. 6 iters. CG1. It's exactly the same. This is the script. Learning rate 10 05 1 clip 01 pixlam 001. Yep, that's it. And then I save this to disk. And then I save it to models knee circular model coil loss, and I see the folder. I'm right there. Norm1 map size 15.9. Maybe I shouldn't copy best weights. Okay, fine. Let's do it this way. Let me take a checkpoint, which is like, let's take checkpoint 19. Nah, but I don't think so, because it wouldn't like, all the checkpoints are fine. Like even after one epoch, this thing generally works. So I just copied over. So let me try with checkpoint. At this point, it's probably easier to just retrain it, because I remember I was doing this on a single GPU. Like batch size is 1, and I have a bigger GPU at home than I had 6 years ago in the lab. So it's probably the fix is to just retrain it for the person and re-upload it and whatever. The only problem is it's gonna take like 5 hours to download the terabytes of fast MRI, but I don't care. I'll do it. Well, okay, so let's try this magical epoch 19, but it's not gonna be this because it works. I'm missing one minor detail, or maybe the data is just bad. Yeah, it's still garbled. So what else do I do in train? So I saved to this directory. I found the directory, train data set. I load it exactly the same because num slices, so it's literally, oh, you know what? What if I change the code for these? Okay, so here's what we can do. So let's take over okay, let's do it this way. Let me just copy everything I had. All the files in grad school. Is it possible I uploaded the wrong code on GitHub? Well, actually, this is a good exercise. So let's do it this way. So I go to the folder and I'm going to copy the most two important files, which are probably the only ones. It's... Aha. So where do I import this from here? Oh, see, it's aux generators. There may be a difference here then, because I renamed the files. So if I copy aux generators over, okay. And now what? On GitHub, I magically call it datagen, but it's supposed to be the same file. Okay, so here's what we do. I delete datagen, and I rename this to datagen, and I do a git diff now. So git diff datagen. Okay, I need to see more here. Okay, there is some differences, but nothing. No, this is just a spacing direction. Okay. Okay. I don't need the permute. Hard-coded for 4. Is it possible I slipped? Yeah, there are some differences, but then... Oh, is it this scaling? What is this? Data full range? No, because I delete... I think it is this. Do I use this though? Like, no, I deleted this because I don't use data for range. Or do I use data for range? Okay, if I try to run the code now, does it work with this file moved in? I know what's happening. So I don't have the key there, even here. This is the key we deleted at the end of the stream. So I was relying on, so what do I do in my training code with, okay, how about we do it this way then? So in the, so do I do something with it? Where do I get the model from? Aux unrolled complex MODL. So do I do anything with data range here? I really doubt it. I think that's just a dead parameter. But maybe I am relying on the RSS somehow. I think it smells like a normalization issue then. Okay, I have to restore the data gen. So that's easy because we just do git restore data gen. Okay, so this should run again now. Why do I try to access reconstruction RSS? Because I didn't restore the file. What? Git restore data gen. Oh, I'm so dumb. I had changes and I didn't stash them. Okay. Aha. So this is. So why would I need this ref RSS here? We went through this before. It's because I do a data range, but then I don't do anything with this. Because data range doesn't appear here. Oh, it appears for the... okay, it's just for SSIM. This is why I need this, yeah. Okay. So this is actually going to be important for training too. Did FastMRI change their data somehow or? Data range. So I can cut this, I can cut this, I don't need this. And then I can cut the load too. And now everything should run like it was, yeah. Oh, I forgot to save again. Where? Oh, I need to cut ref RSS too, yeah, because I don't need this. Yeah, this runs, but of course the plot is busted up still. Hey, thanks for joining. Thanks for chatting. Just going insane. It was supposed to be like a 30-minute stream, but I can't figure out why this is wrong. It's definitely close to this circular model, or at least that model should work. Trying to fix one of my grad school repos because somebody's using it after 5 years. Okay, I can YOLO a scaling here. Well, let's actually debug it. Wait a second. Let me look at the same energy experiment. What is, okay, hang on. We can tell if we're closer or not. A lot, because we can check the energy of the central line, and let's see if we're a bit closer. So I know I have 336 lines in sample K space. Okay, so input K space will be sample K space dot 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 0, because we have turn complex, plus 1 J sample K space dot 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 1. And I want to see torch sum, torch square, torch abs. I want to see, well, let's just do some abs. No, let's do square. No, let's do abs. I've been coding in Python for some years now. It's got to be like 9 or 10, but mostly PyTorch, to be honest. And derivatives of so what do I want to see here? So I want to see the sum of the input, the power, the energy in the input K space on dimensions. Oh no, because I want to see line 168, which is the center. Okay, yeah, I never did do lead code style though. I'm not too good at that. Torch sum, okay. Okay, I see, it's TH. Okay, so I go in with 16 energy. Isn't this like gigantic? What the heck is going on here? Oh no, because I sum across the coils too. Oh, okay, so let's do it. Let's just... This is still law. Okay, something is fishy then. Wait a second. Wait. And what do we come out with? Okay, this looks way better though. I'm pretty close. Wait, but the problem is... Oh, did I save the data wrong? Wait, we're much closer now. I think we got this. Because what happens if I move back to the... Did my IFFT mess up the data magnitude? Is this like a non... It's supposed to be ortho. So then when I crop, don't I take energy out? Okay, so let's go back to the raw data. What is the energy of that? Data raw. I think I messed up the crop, which is good. Do I have the breakpoint? I do not have... Oh, I do have the breakpoint. Okay. Yeah, the funny thing is PyTorch is probably easier than LeetCode, to be honest. Like, it's all just... Well, the matrices are the most related thing here because we work with like 4-dimensional data and stuff. What energy was I looking at? The sum of the absolute estimated K space. First sample, first coil. Oh, that's so funny because I actually do Rust at work. Yeah, it's a long story, but yeah. Well, if you look at my GitHub profile, I work on C to Rust translation with. I don't need to know. I work on C to Rust translation with AI, so like written in Python. It's like a whole thing. Where do I noise K? I don't need to. What do you mean? It's like... Does it say I noise it in the paper? I don't think so. So if I sum the absolute values... Oh no, this is good then. So what is input K space? Am I in data raw? Yes, I am. Where didn't we see like... Maybe I was looking at square. I think it was square. Huh. Why are we seeing power so much larger now? Oh, actually I have this. It's under sample complex. So I can just paste here. Oh, I can't paste. I can't do it like that. Okay, wait a second. I'm definitely messing up the... What is the... No, because I lose energy, but why was it so high before? F15 numpy. So what, do I add noise? No, but this is the fast MRI data set. So when you load data from MRI, it's already noised. We actually don't do anything with the noise power though in the algorithm. We don't need to know what it is. We just ignore it. So then we just sample it, and then when you sample it, it's yeah, there is maybe some inaccuracy here because we cut some lines, but yeah, this is how we do it, because you can't, because the thing is the raw data comes with noise already. You can't even separate it from A times K, unfortunately. But I don't think we do anything with the noise power. Definitely, I do not remember adding noise. Hang on. I want to see, I think I'm doing the cropping wrong. I'm doing some trickery here. So yeah, so the fast MRI data is A is I, so it's just K plus N. That's the file I'm loading basically. That's what it's just K plus, because A is identity. Because it is fully sampled. Okay, so fast MRI, the ground truth data, you get it fully sampled, but you get it glued. You can't separate K from N. So you directed K. The slight inaccuracy is that we don't do AK plus AN. Well, no, actually we do, because we mask. Oh, never mind. So there's no inaccuracy, so it works. Actually, I abuse notation here, but crop is true. Let me see what's happening with the crop here. Maybe there's some hope. Maybe I cropped wrong here. Oh, yes. There we go. Oh my god, dude. I'm so fucking... Okay, we're back now. Check this out. Because if in NumPy, if you make a real tensor and you assign Jesus Christ. You have to make a complex tensor. Otherwise, it throws away... So we throw away the imaginary part. I swear this is it. So this has to be NumPy complex. Do I have 128? No, just NumPy complex. I guess at the time they didn't have it. All right, like this is insane because we were actually casting complex vector real, discards the imaginary part. So when I was assigning here, this is a real tensor. Then, okay, we threw away half of the info. This is the final one. It's gotta be this. No, I forgot. I have to switch from the... oh, okay. I gotta switch back to data and crop false. Ah, did I corrupt the files? Damn it. What if I saved it? Where did I stop? I think I corrupted the files. Okay, I'm not gonna risk it. So... No, I didn't because it... Okay, never mind. So delete this. False data. No, I'm so dumb. We have to recrop, right? Because the data was corrupted. Okay. Okay, you know what? Just delete data. Wait. Crop dir is data. OS make dirs crop dir. So we can nuke this. And then let's save it in crop dir. Oh, for God's sake, I need to change the path now. Okay, so I need more pathlib shenanigans. Pathlib, how to change base or first directory and path. So if I have original path, oh my God, I have to take the parts. Okay, we're doing this nice. I don't like this. So file. This is the thing. We don't need this. I'm not doing regex. That sounds way worse. So here's what we're doing it. So it's gonna be crop dir. We don't need the crop suffix because we save them to different file folders anyways, right? So that's actually the trick. Slash path file. That's it. We just copy. Wait. No, it's path dot. I believe it's name. This one we can test quick. UV run Python. So if I have import path, a equals path of stuff file dot x, a dot name. Yes, okay. So that's it. So I just take the file name, the last file name, and I put it in crop dir, and we're done. So no more shenanigans. We can actually do this right here. Yeah, so we don't need a new string. Save to different folder. And that's it. So we save to crop dir, cropped file. Okay, so let me breakpoint here because this is a wobbly thing. So it's gonna save to crop dir. So we should see it created. I swear this has to be it. I think it's gonna work. Did not make the plots folder. I did not make. I have to make it earlier. That's what happened here. So make the plots here too. Exist okay true just to be safe. Data is empty. I hope I didn't modify this data. Just because I'm paranoid, I think I'm gonna delete this and paste it again. Okay, it's taking a while because it's doing the 16 million plots. Oh no, but no, this confirms we didn't mess the data, right? Because it looks good. These coils look good. Come on. Okay, I wrote the first file. I'm tempted to not even wait, but it's fine. Writing the second file, so then I have to switch this back. Core dir will be data and crop will be false, and that's it. I load the files. Okay, there we go, we're done. This should be cropped, false, and go to, whoops, data. Right? Yes. I don't need the plots. Is the model circular? What model am I using? Oh, I'm using the checkpoint. Fine, it's from the same folder. It shouldn't matter. It has to be this. Like, there's no... It's still not this. So I get the undersampled. Estimated coil. We gotta check the data. Maybe I fiddled with the... Did I overwrite the data in place? It's not a square thing though. I'm pretty sure this is supposed to be, it wasn't 320, but why? Okay, so then we need something else because let's work here. Let's do it this way then. Raw dir is, let's change the logic so we don't have to breakpoint the code anymore, okay? So we'll do it this way. Do crop equals path raw dir, no, core dir exists. So if, no, it's already cropped. All right, so then we can say if it's not already cropped, which means the folder does not exist, then we're gonna put it here. And that's it. Then we always load core dir, right? So now the only thing I'm paranoid about is, I'm gonna delete these, and I'm gonna copy the files over again. I wonder if I messed with these. So we can also delete the data folder. And let me copy back data raw from the downloads that I did, which I know are hopefully untouched. I don't even know. The other thing is that I found these two files, the raw files from another one of my repos where we sort of leaked them. You're not supposed to put these online, but we did. I'm pretty sure these are untouched fast MRI files though. Okay, so we have data raw. Core dir should be false, right? Because this won't exist. Let's see. Already cropped. Yeah, it's false. Okay, obviously I need to make dirs. Core dir. Exist OK is false because we want this to crash if it tries to overwrite. And this should be it now. So now I can run the crop and the thing in the same. I'm gonna cut the plots because I don't like them and they take up way too much time. So what I want to see here, and I'm gonna delete one of the files. We don't care about two data files. One is enough, okay? Okay, so we have a single file. This will be to do it. We're gonna do all the slices. So k-image crop should be a full thing. Okay, let's validate that the crop is okay. I want to check the energy that why? Because this folder magically exists somehow. Who made this? Who is making this? I have to look after cropping. No, wait. So raw files. I think there's a logical mistake here actually. Okay, so I go on the raw files and I save them, and then my validation files are here. Oh, I think what's happening here, like Glob is creating the thing and these are in core dir. Who is creating this data folder though? Okay, now it's really loading and cropping. No. Oh, yes, it is. Oh, I see. It's just faster because we didn't plot. Okay, good. This is how it should be. So, I have k-image and k-image cropped. That's it. So kImage.shape, kImage cropped. Sure. So slice 20 should be, or even 15 should be okay. So what can I do here? Let me check the power. NumPy square absolute of kImage, slice 15, all the coils, and actually everything. And how much do I have the cropped power? This makes sense because we cut dark space mostly. It's okay, so this is good because the vertical, the top and bottom are vertically. Let's just plot one just for safety then. PLT figure, PLT im show. What do I have to do here? IFFT, tensorize. I need a slice and a coil. So I need kImage cropped, slice 15, coil 4. That's it. IFFT of this. In NumPy. CMap gray. Aha, I forgot. It's absolute. I can only plot absolute values of the IFFT. Okay. Okay. PLT axis off. PLT save fig. Check plot PNG DPI 300 VBox inches tight. Wait, is it? Yeah, it looks like a crop knee in the vertical direction. So the cropping works, yeah, it works in the image space, and then it goes back to K space, and then we go back again to image space with IFFT. Same energy, same magnitude, everything looks in order. Okay, PLT close. C. Let's continue. Maybe the files were corrupted because this is with a fresh file. So now I only have sample 0. I can delete sample 1. Oh, I see. It's estimating slices. Yeah, so these are undersampled. Nah, they're still not, something is still not right. It's definitely wrong. Let's see what energies we come out with. So now if I run this again, it should not, it shouldn't redo the files if my logic is right. Okay. So what do I have here? Undersampled complex. Dot. Whoops. Shape. What can I do here? Torch, sum, square. Just the whole energy. Now this is different because it's renormalized inside the thing, and I come out with what? Estimated K space. Yeah, this is blowing up. Something is okay. So this feels out of distribution somehow. Am I missing a normalization factor? Am I missing? I believe I am missing a normalization factor. Could it be the ACS one? Okay, let me YOLO this then. So, sample, k-space. If it amplifies, I'm gonna guess I should divide. Okay, so let me delete the plots. Now I'm seeing 2 because it takes 2 slices. Is this closer or farther away? I suspect the data I was using was like somehow pre-normalized, but I lost that code. It must be that. So I wasn't really working with raw MRI files. If I divide it by 100, do I get something different? Maybe the data is already too tiny then, and I need to amplify it a bit. Ah, yes. Fuck me, finally. Yes, it is the scaling. Okay. So this is way closer. Oh my god. So how was... Yeah. I knew it was gonna be this. Okay. So then I just need to remember how the heck was I normalizing. It's definitely division. Yeah, it's exactly what I replied to the guy actually, which is really funny because we spent all this time. But then I replied to the person... I suspect as we pre-processed the raw... Yeah, okay. So we're... Yeah. So if I guess this factor, it will become in distribution for this. Can I guess the factor? Probably not. It's impossible. God knows. But I'm trying to remember... Okay, so unfortunately this is not fixable. If I lost that code, it's gone forever, but I can just retrain the model now. And that's it. Is it more than this? Or did I overshoot? Like what if I normally minus 2000? Okay, not the worst. We kind of sorted through. I mean, we wasted a ton of time. This simple line could have fixed every... Well, not really. No. Because first of all, we had to fix the vertical thing. So that was not a time waste. The problem is now guessing what this was is virtually impossible. Let me see. Did I even run this? Yeah, so we don't need all this. We don't need this. Okay, so we can do this. If I analyze the raw data, I can probably reverse engineer what I did. Okay, so we overshot with 2000. Is it like... Okay, so let's do it this way then. Okay, good. So we know there's a fishy factor somewhere relative to what comes out of the data loader. So now, if I just look at the data, can I guess what that factor is? So I have sample KSP, right? Can I guess what I need to divide it by? It's not an easy guess. First, I would turn it to complex, right? So I would say KSP ... 0 plus 1J sample KSP ... 1. Okay, so I have a KSP dot shape. Is it the total energy? Is it the square root of the total energy? Some square of absolute of KSP? Nuh-uh, it's way too small. But what would it be then? So this energy is too high. Is it the number of lines? No, if I take the energy of the central lines, that's strictly smaller than... That's lower, so that's not good. So it's across coils. What should I divide it by? If I square this, it doesn't make sense though to divide by this, right? I mean, I can try this. Maybe it is. But then if you divide, square root would make a lot more sense. Let's try this then. I didn't save, of course. Nuh-uh. It's not this one. What is the data before going through the data loader? Is it possible my data loader is messing up things here? So let's see here, use ACS. There is normalization happening here. There we go, K normalized image. Max ACS. Is this bad? Should I re-multiply? But let's see what this is then. Maybe there's some trickery here. So what is max ACS? What is 1 over max ACS? This is suspiciously close. Should I not do this then? Am I tricking myself by normalized K-space based on ACS? But then what does my training script do? The thing is, it does the same. Oh, whoops, this one. So it takes the data. So it loads, and this comes from aux underscore. Maybe there is a difference, like we tried to find out here. Oh, don't tell me there is. There's a crop and a crop complex, which I don't think are used actually. Yeah, they're not used here. So I do take the max ACS. No, it's exactly the same thing though. Do I have GTKSP, which is just a K image, but with deleted lines? So this is fair game then. Oh no, well it's not, but... So where's K image coming from? Yeah, it's directly loaded from the K space. Do I undo this somehow? No, I can't. I wouldn't do that. Skipping scan, we solved this problem. And then that's it. I just call the model exactly like I call it. And then sure, this is all the loss function. It doesn't matter at this point. I think I have to train a new model. I can't. It's not the sum of squares for sure. Do I have the max ACS stored in the data set? I believe I do actually. I do not. But this looks like something important. So I never did on the outside then. Okay, so then what I can do is I can get this and then I can just reverse it. But I doubt it's gonna be this then. So data gen, and then we have this. So then I can just say times sample max ACS. Is there anything else used by the model? Okay, so let's do it this way. What do I reach into sample? Okay, where's my sample? Where is there not a forward something or? Oh, I see. It's called different, I guess. Where is it for data? So KSP and mask. Is that this is everything I use, right? Oh, I see. I use init maps. Oh, am I messing these up? Ooh. I'm in estimated mode. So what is init maps in the reference code? It's just this, sp.resize.spfft xcoils xrss. And what is it in data gen? Init maps. It's the same thing. If I copy this over, it'll be exactly the same. Well, actually, do it in reverse. If I copy this over. Yeah, no change. Okay, so the init maps are exactly the same. I don't need this data range. It's just for loss training. Yeah, so let me try to, what do I do here? Let me remultiply, I guess denormalize. This is a pretty desperate attempt, though. It's not gonna be it for sure. I messed up the data too now. Because I'm guessing this is a float, right? So torch.tensor. I should tensorize it. Yeah, it's float 32 versus 64. That's what's happening there. Okay, well, it's fine. Then we'll just train another model. It's probably like I could have... What the heck, dude? Why? So what is sample ksp.d type? Before? (32), and this is what, 64? Yeah. So then we need to say 2 torch float 32, because we can't multiply double with float. Oh, whoops, I forgot the thing again. Kind of close, but it's not. Nah, it's not actually working, right? No. But what does it mean to take the max of the ACS? Oh, it's the absolute. Yeah, it's probably easier to train at this point because I would have to just do what? Yeah. Actually, the script would just work, honestly. And it will just work. yeah, it even has preload, extra padding, convert, RSS. Where's the loss function? Oh, here it is. SSIM, data range, sample data range. So yeah, I need the fast MRI. Yeah, I lost the fast MRI. Yeah. But interestingly, this is not. I think we're pretty close, but the data, I wonder if it's mismatching or something. Okay, so let's do this. What if I try now? Wait a second. What if I now try this, but with downsampling 1? This should be a lot better now. Yeah, and it is, well, it's still off, right? Yeah, no, this is off, you can tell. Oh, the knee is fatter too. I wonder if this is the wrong data then. Yes, it is. Right. Because it has 3. No, but wait. How many does it have? How many case space do I have here? No, 336 was trained on for sure. Wait, in my training script, do I have the skip here, skipping a large sample or whatever? I do not. Yeah, it's probably easier just to train at this point. So the other thing we can do is we can fix the CUDA issue, which is kind of unrelated, but at least we'll get to run on GPU so that I can train. Okay, so it didn't work out. I don't know what to do, so I give up with this one. So what did we change here? Git diff data gen. Yeah, we have this thingy here, which we need. So I'm gonna git commit, do not reference mysterious field. What else did we change? Git diff. Oh, we changed something in models. Oh yeah, we changed the don't hardcode CUDA stuff. This one we kind of need though, because otherwise the code is broken in other ways. And what did we change in PyProject? Okay, I would change NumPy. So git add PyProject UV lock, commit, downgrade NumPy. Okay, so how do I enable Torch with GPU now? Interesting. So 1.9. Pip install plus Q111. 190 plus Q111. Is it this? Let's see. No, it's not. Because I need a package index. What is at this link? I think this link is stale, that's what's happening. No, there are wheels here. So are there wheels for... Yeah, there are wheels for 190. Yep, Python 3.9. But no Windows? Okay, so... Does this even work on Windows then? Well, let's do it this way then. Why don't I just do, because UV has pip mode too. So UV pip install. Oh, this does work. Oh my god, okay, so it's all here. Okay, well this is good. At least we can install PyTorch. Actually, I don't need the torch vision. I just need to figure out how to pass this -f. So what am I missing here? Yeah, torch. Cool111. Can I capture the environment somehow? Because it's really annoying. Using a PyTorch index. UV pip install -f flag. What is UV pip? -r. What is -f? Where's the full documentation for this? Okay, so this works. So what do I do here? 190 plus cool111. But it's because I... So how do I specify the sources? Because it's this .f thing. So it has to be here in UV PyTorch. Where's the source? So I need this, and I just need one of them. I don't know why I don't care about this. So then I do 111, okay. And then I need torch, sources, index. Oh no, this is for CPU. Oh, and then I need the UV index. And it has to be called PyTorch cool111. And the wheel should be torch underscore stable, I guess .html. And I should do UV sync. No, why? There's no version of Torch. System Linux is Torch. Maybe I don't need this. I'm gonna cut this thing here. Let's see. Torch was not found in the package. Maybe it's with this. This is so annoying. UV has a weakness here. So what I need to... No, but I need Q9. Yeah. Maybe I don't need that. Install PyTorch 190 with GPU and UV. I mean, I can do the pip. Aha, is it Q111? Or is this a hallucination? Oh my god, is this it? Ah, yes. Okay, my bad, because you have to go. So what do they want here? Q111. Okay. So then do I need to put plus Q111 here too, or no? I guess I just do torch. No. But this I don't have here, why? Because I'm literally here, right? Oh. Oh yeah, .html. And there's no PyTorch. Yeah, there is no PyTorch. Oh, I see, it starts from 1.11. Did they take it down or something, or what's happening here? So which one do I need then? 10.2. Well, please tell me at least. So I go to the index, what, Q10.2? .html. And do I have PyTorch? Do I have torch 1.9? I don't have it here either. Hey, thanks for stopping by. We're dealing with a bunch of PyTorch crap. Oh no, it is here. Okay, so they're all here. My bad. Yeah, so 1.9 for 3.9. Yeah, okay. Oh, here it is. Windows AMD. Actually, it's here. Okay, alright, so something is fishy, so I guess UV just refuses to work. So this thing works. Do I just leave it torch? Is it .html? Oh, thanks for the follow. Yeah, we're oh, come on, because I know the UV pip works. I mean, it's actually done. Yeah, so what am I missing here? Because I could just do this. Yeah, so I mean, this can always be solved manually, but it's annoying me that I can't solve it through a single, just a nice clean line. Let me try 10.2. I'm pretty sure this number doesn't matter. Yeah. 190 channel PyTorch. So we need the wheel for sure. I don't know. I've only done coding on this channel. No games. Okay, well, I need to understand what this F flag is then. So UV pip help. Okay, well, that doesn't work. Oh, it's dash dash help. F. List and requirements, cache, Python knowledge, Python global options. Well, this is not too great. Is it freeze? It's not freeze though. No, it's UV pip install help. Find links. Let's leave that for another time for now. Hang on, I gotta solve this. So what do they... Instead relying on direct dependencies. Aha, so it's not an index. Okay. I get what this is. So UV pip find links. Yeah, I can give you a follow. Yeah, I just gave you a follow. And that's uh, uh, I don't know what you're talking about. Like add you to what? Okay, so hang on, I have to. Oh, okay. I'm not really on Discord. Sorry. Dash F. So what do they want here? Find the links. Locations to search for candidate distributions. Here it is. Jesus fucking Christ. So I need this. Wow. Okay, so it is possible to do it. Okay. Finally. Okay, so actually the only thing you need is find links and then you do plus cool111. Okay, so now UV sync, fine. Oh, come on, really? Oh, because it's not. Wait, I copied that. It should be cool111, right? Fail to read, find links. Where was I looking at those things? Is it not this? No, it's not. Is it like WHL? Yes. So WHL slash. Okay. Did I not save this? I didn't save it. Yes. Okay. Finally. Okay. At least I learned something new. So UV lock, git commit, add PyTorch for GPU. Okay. Now training should be easy. So because now we have the GPU unlocked. This was not that easy though. I had no idea that this would work like this. Okay, so I'm gonna stop here. But yeah, thanks for watching. For everybody that stood by through the torture, we didn't really solve the problem, unfortunately. So I guess I'll download the data offline, and well, at least we'll have some fun training the model. Which, oh my god, I really hope that training script works, and the loss really has to go down. But then the thing is, if it doesn't, this is definitely the code from grad school. So this definitely works. Yeah, because we're doing some trickery here with skipping samples. So I think we can, yeah, we can make this work. We'll pre-crop the data like we did because we have that, and then we'll train the model. That should be it. Yeah. Okay, I'm gonna stop here. Thanks everyone for joining. Well, I think I may skip the later stream, but I'm not sure. Yeah. Okay.